Hello everyone, and today's topic is linear independence. See, a finite set of vectors S in V is linearly independent if the only linear combination of distinct vectors in S that produces the zero vector is a trivial linear combination. Okay, that is, if Vi are the distinct vectors in S and its linear combination is this, then the scalars must be equals to 0. Okay, and if any scalar is not equals to 0, then the set of vectors is called linearly dependent. Okay, now see, if we are given two vectors, say u is equals to 2 minus 3 and v is equals to 6 minus 9, then if we are asked to find whether these vectors are linearly dependent or independent, we can see that here v is equals to 3 into u, isn't it? See, so therefore the vectors are linearly dependent. Okay, now see, here are some important points that we need to remember. Okay, that is, two vectors are linearly dependent if and only if one is the scalar multiple of other. Okay, for example, if one vector is 1 1 and the other is 2 2, then we can see that this is the scalar multiple of this, isn't it? If this is v and this is u, then v is equals to twice of u. So therefore this is these are the linearly dependent vectors. Okay, now the next point is any set containing the zero vector is linearly dependent. Okay, then the next point is if a subset of v1 v2 up to vk is linearly dependent, then the set of v1 v2 up to vk is also linearly dependent. Okay, now the next point is a horizontal matrix, a matrix with more columns than the rows, has linearly dependent columns. For example, see, if I take the example of horizontal matrix means a matrix with more number of columns and less number of rows. So let us take 2 cross 3 matrix. Okay, so here this will be something like this: 2 rows and 3 columns. Alright, so a horizontal matrix will always have dependent columns. Okay, so for example, 4 vectors in R cube are automatically linearly dependent. See, the dimension of R cube is what? 3. Okay, so if 4 vectors are given, then automatically it will be linearly dependent because one vector is going to be the linear combination of other 3. Okay, so therefore this will be linearly dependent if 4 vectors are given in R. The next point is if S is linearly independent, so is any subset of S. Okay, then the next point is if S and T are linearly independent, so is S intersection T. Okay, next, the empty subset of a vector space is linearly independent because it has no members. Okay, so therefore it is linearly independent. So see, the first question is determine whether the vectors this, and this are linearly independent or not. Okay, so there are actually two methods of solving this question. The first method is either we can make the linear combination of these three vectors along with the unknown constants and equate that to 0, and after that we can solve to get the unknowns, and if we get the value of the unknowns to be 0, then that will be linearly independent, else that will be linearly dependent. Okay, or we can use another method that I will be showing. So let me first do with method 1. Okay, so method 1 is let me write it in the form of linear combinations. So let the unknowns be x, y and z. Okay, so x into 1 minus 2 1 plus y 2 1 minus 1 and this is z into 7 minus 4 1, b equals to 0 0 0. Okay, this is plus. Now this is equals to x minus 2x comma x plus, this is 2y comma y minus y, and plus this is 7z minus 4z comma z is equals to 0. Okay, next this is, we will add this, and after adding we will get this as x plus 2y plus 7z comma, this is minus 2x plus y minus 4z comma, this is x minus y plus z is equals to 0 0 0. Alright, so after this we can reduce it to the echelon form to get the solution easily. Okay, so this is equals to, when we will write it in the matrix form, then this will become, so we will write it row wise. Okay, that is 1 2 7 and this one 0. So see, we will get this as 1 2 7 0, and this is minus 2 1 minus 4 minus 2 1 minus 4 0, and the last row is 1 minus 1 1. Okay, 1 minus 1 1 0. Alright, now we will be reducing this to the echelon form, and that will give us 1 2 7 0. Okay, and now this one, r2 is equals to r2 plus twice of r1. Okay, so this is 0 and this is 5, this is 10 and this is 0. Okay, and r3 is equals to r3 minus r1, so this will give us 0, this is minus 3, this is minus 6 and this is 0. Alright, now see, what we can do, that this r2 can be written as r2 equals to r2 by 2, and then this also can be done, r3 is equals to r3 by minus 3. Okay, so see what we'll get after that. So this is equals to 1 2 7 0, this is 0 1 2 0, and this is also 0 1 2 0. Okay, now we can see that these two rows are same. So now r3 is equals to r3 minus r2. When we will do, then we will get this as 1 2 7 0 0 1 2 0, and this will be 0 0 0, here also 0. So what we can see from this, that we will get non-zero solution, because these two, we are getting two equations in three unknowns. Okay, so we are going to get a non-zero solution. That means the vectors, the set of vectors are linearly dependent. Okay, or we can also do this by the second method, that is, so method 2 is directly writing these vectors in the form of columns, like write these vectors as C1 means column 1, then this one is column 2 and this one is column 3. So see, let us take this matrix as A. So A is equals to 1 minus 2 1, this is 2 1 minus 1, and this is 7 minus 4 1. Okay, now we will reduce this to the echelon form. So similarly we will get this as 1 2 7, and this is r2 is equals to r2 plus 2 r1, so this is 0, again this is 5 and this is 10, and r3 is equals to r3 minus r1, that is 0, and this is minus 3 and this is minus 6. Okay, so now this will reduce to, similarly just as before, 1 2 7 0 5 10, and this will be 0 0 0. Now see, as this echelon matrix is having 1 0 row, so therefore the set of vectors is linearly dependent. Okay, now if the vectors are 1 minus 3 7 0 0 0 and this is 1 2 1, then if we are asked to check whether these vectors are linearly independent or not, then the answer is no, because see, because of this 0. Okay, because of this 0 vector. So wherever there is a 0 vector, that will be linearly dependent. So therefore these vectors are linearly dependent. Okay. See now, the next question is, show that the vectors u is equals to 1 2 3, v 2 5 7 and w 1 3 5 are linearly independent. Okay, so we will form the matrix. Okay, so let the matrix be given by A, and this is equals to, we will write these vectors in the form of columns. Okay, so this will give us 1 2 3, this is 2 5 7 and this is 1 3 5. Alright, now we will reduce this to the echelon form. Okay, so this is 1 2 1, r2 is equals to r2 minus 2r1, so this is 0, 5 minus 4 1, 3 minus 2 1. Now r3 is equals to r3 minus 3r1. Okay, so this will give us 0, 7 minus 6 1 and 5 minus 3 2. Okay, so what we can see is, now this is 1 2 1, this is 0 1 1 and this is, see, we can do this as r3 is equals to r3 minus r2. Okay, so this will give us 0 0 1. So what we can see that every row is non-zero. Okay, so therefore these vectors are linearly independent. Alright, because if you write this in the form of linear combination using the unknowns, then we will get the value of those unknowns as equals to 0, like x, y, z all will be equals to 0. So therefore this will be a linearly independent set of vectors. Okay, so this is the end of the video, and if you liked my video, then please do like, share and subscribe my channel. And also if you have any doubt regarding this topic, then you can ask that through this comment section. Okay, so thanks for watching my video. Bye bye.